Hi students, how are you? So welcome to today's class. Today I am going to discuss a few problems from the textbook Sange's from the chapter Maxima and Minima. Okay na? So let us start our class. The first problem of today's class is discuss the extremum of the function f of x is equal to x minus 1 into modulus of x minus 2 into x minus 3. How many critical points are f of x has and draw the graph of the function. Okay now, right. So these type of problems will be asked in JEE mains examinations and also JEE advanced examinations. Okay, so let us discuss the problem now. So first given function is f of x is equal to x minus 1 into modulus of x minus 2 into x minus 3. Okay now, so this is a modulus is up to x minus 2 and x minus 3. Observe the sign change of f of x at x is equal to 1, 2, 3. Let us see what happens. So this is equal to 1, 2 and 3. If you take any value more than 3, greater than 3, what happens you see here? If you take any value greater than 3, 3 minus 1 is positive. So anyhow this value will be positive. Any value, for example, if you take 4 minus whatever may be the value you take, that will be positive. So here if x is greater than 3, the function is positive. If any number which you take 2 and 3, between 2 and 3, if you take 2.5 minus 1, how much? It is a positive value. Almost this is also a positive value. Why? Because it is under modulus. So this is also positive. If you take any value between 1 and 2, if you take 1.5, 1.5 minus 1, 0.5 positive. If you take 1.5 here, it will be negative, it is also negative, negative into negative, positive, whole becomes positive. Okay na? So here also you will get positive. If you take any number less than 1, for example, if you take less than 1 means then x minus 1 is also less than 0. So less than 0, that means it will be negative. Even though you will get positive here, so negative into positive, negative you will get. So this is the sign scheme. Okay now let us draw the graph. First of all I will draw the graph, then afterwards we will see the critical points. Okay, so the graph will be like this. So let us take this is x-axis and it is y-axis 0, this is 1, this is 2 and this is 3. 3 greater than 3, it will be positive like this. 2, 3, it is also positive. 2, 1, from 1 and 2, it is also positive, that means positive y-axis. From 1 onwards, it will be negative. This is the graph of the function. This will be the graph of the function. Understand this? Clearly, if you observe at the point 2 and 3, the graph has sharp edges. At x is equal to 2 and x is equal to 3, f of x has sharp edges. Therefore, f is not differentiable at x is equal to 2 and x is equal to 3. Therefore, these 2 and 3 are called critical points. 2 and 3 are critical points. Okay na? Critical points. 2 and 3 are critical points. Here x is equal to 1. The function is differentiable. Why? Because here there is a sharp edge. Okay now what is the point of maxima? Point of maxima. For this finding point of maxima, since here 2 and 3 are critical points and here 1 is also from 1 to 3, there is a chance of getting a points of maxima between 1 and 2 and 2 and 3. For that, let us find out that. So f of x is equal to, your function is x minus 1 and x minus 2 and x minus 3. I removed modulus. Why modulus I removed? Because see here, everything is positive. Between 1 and 3, the function is positive. X minus 2, x minus 3 is also greater than 0. That's why I removed the modulus. Now let us see here f of x is equal to, so if you multiply this, x minus 1 into x minus 2 into x minus 3, if you multiply this, you will get x cube minus 6x square plus 11x minus 6. Understand this, you will get x cube minus 6x square plus 11x minus 6. Now f dash of x, so 3x square minus 12x plus 11 is equal to 0. For a maxima and minima, we have to get f dash of x is equal to 0. Why? Because if you draw a tangent at this point, these are parallel to x-axis. Therefore, f dash of x is equal to 0. So, this is a quadratic equation. If you solve, x is equal to minus b plus or minus root of b square, that is 144 minus 4ac. 4 3s are 12, 12 11s are 132 by 6. This is equal to 12 plus or minus root of 144 minus 132. So, this is equal to 144 minus 132, how much? 142 minus 132, 0, 10. This is a 10 by 6. So, if you separate that, you will get this is equal to 2 plus or minus root 10 by 6. 2 plus or minus root of root 10 by 6. Okay now. Right, let us check our answer. So, 3x square minus 12x plus 11 is equal to 0. So, x is equal to minus b plus or minus b square means 144 minus 4ac. 4 3s are 12, 12 11s are 132. So, 144 minus 144, this is a 144 minus 132. So, this is 12. So, this is equal to 12. Okay now. So, this is a root 12 by 16. Root 12 means what? 2 root 3 by 6. So, this is equal to 2 plus or minus 2 root 3 by 6. So, this is equal to 2 plus, so root 3 by 3, that is equal to 1 by root 3. So, 2 plus 1 by root 3. So, at x is equal to 2 plus 1 by root 3. So, you will get here point of maxima. 2 minus 1 by root 3 also points of maxima. So, 2 plus or minus both will be there. 2 plus 1 by root 3, 2 plus or minus 1 by 3, both are called points of maxima. Points of maxima. Okay now. So, so these are all understand this. So, to get the maximum value 2 plus 1 by root 3, substitute here in this 2 plus 1 by root 3 and 2 minus 1 by root 3. You substitute here, you will get whichever will you get, that will be your final answer. Okay now, right. So, this is a very, very easy problem. So, the only thing is this modulus, don't get confusion about this modulus. You can see this modulus as a very, you can remove this modulus by taking the sign scheme easily and draw the graph. Okay na? So, I hope that you understand this solution. So, let us go for next problem. So, dear students, welcome to this problem. So, the problem is find the points of extremum of the function f of x is equal to 2 secant x plus 3 cosecant x in the intervals 0 comma pi by 2 and pi comma 3 pi by 2. So, this is a function. We have to find out points of extremum. Points of extremum means maximum and minimum, that is global maximum and global minimum in this interval 0 comma pi by 2 in pi comma 3 pi by 2. We don't know whether in which interval you will get point of maximum and we don't, you know, in which interval we will get point of minimum, we don't know. So, we have to proceed. Okay. So, then how to proceed? So, let us see this problem. So, here the function is given f of x is equal to 2 secant x plus 3 cosecant x. So, for maximum or minimum, for to get critical points, we have to find its first derivative. So, what is the first derivative of this function? F dash of x is equal to, so 2 into secant x derivative, 2 secant x into tan x. Okay. Cosecant x derivative minus cosecant x into cot x. So, minus 3 times cosecant x into cot x. So, for maximum or minimum, you have to get this is equal to 0. So, this is equal to 2 times this is sin x by cos square x. Why? Because secant x means 1 by cos x, tan x means sin x by cos x. So this is equal to cos x by sin square x is equal to 0. Okay now, right. So if you take cross multiplication, since x is not equal to 0 and x is not equal to pi by 2, x is not equal to 0, x is not equal to pi by 2. So you can take cross multiplication. This is equal to 2 sin cube x minus 3 cos cube x is equal to 0. So here cos square x into sin square x, if it goes to right hand side, it will become 0. Okay na? Right. So this is equal to tan cube x is equal to 3 by 2. This implies x is equal to tan inverse of 3 by 2. Sorry, tan cube x is equal to 3 by 2. So therefore tan x is equal to 3 by 2 whole power 1 by 3. So tan x is equal to 3 by 2 whole power 1 by 3. Therefore we know from the trigonometric equation, the general solution is x is equal to n pi plus tan inverse of, so this will be some tan inverse of 3 by 2 whole power 1 by 3. So tan x is equal to tan alpha. Tan alpha is equal to 3 by 2 whole power 1 by 3, where tan inverse alpha is equal to tan inverse of 3 by 2 whole power 1 by 3 we can write. Tan x is equal to tan alpha. Therefore x is equal to n pi plus tan inverse of 3 by 2 whole power 1 by 3. So this is the point. So in which point, this point in which where it is a maximum or minimum, we have to check. Now let us take the first interval 0 comma pi by 2. So let x belongs to 0 comma pi by 2. Then what will be your x? What will be your x? 0 to pi by 2 means there should not be, this is n pi plus, no, that is why this should not be, you have to take n is equal to integer, therefore you have to take n is equal to 0, therefore x is equal to tan inverse of 3 by 2 whole power 1 by 3. So this is a 3 by 2 whole power 1 by 3. Let us check whether at this point it has a global maximum or global minimum. Let us check. Now if you observe here, as a limit x tends to from 0 to pi by 2. So I am taking the interval here. So this is 0 and this is pi by 2. Okay, from 0 to pi by 2, I will approach from here, right hand side limit I will find out, here left hand side limit I will find out. Let us see what happens. Limit x tends to 0, right hand side means plus. What is your function? 2 secant x, 2 secant x plus 3 cosecant x. See here, as x value approaches to 0, as x value approaches to 0, this value approaches to infinity. This value approaches to infinity. That means as x value approaches to 0, 2 secant x plus 3 secant x value approaches to infinity. So that means it will be like this, okay na, right. Left hand, right hand side limit here. So limit x tends to, here you are applied. So here left hand side limit pi by 2 minus 2 secant x plus 3 cosecant x value, it is also approaches to plus infinity. That means see here x tends to pi by 2. You are approaching from pi by 2. 2 secant x plus 3 cosecant x value approaches to plus infinity. That means if it goes to plus infinity, it is going plus. So what you will get, so if you see the graph here, it will be, the graph will be like this. So you will get point of minima. Therefore, in the interval 0 to pi by 2, you will get point of minima. That is global minima. What is that global minima? At x is equal to tan inverse of 3 by 2 whole power 1 by 3. At x is equal to tan inverse of 3 by 2 whole power 1 by 3. That means in this interval 0 to pi by 2, you will get global minima. Understand? That is point of minima you will get. At the point x is equal to tan inverse of 3 by 2 whole power 1 by 3. Let us check what happens in pi to 3 pi by 2 interval. Okay. Welcome back to this problem. Let us say x belongs to the second interval pi comma 3 pi by 2. Pi comma 3 pi by 2 means what? What you have to take? X is equal to, here you have to take n is equal to 1. Okay, na? So n is equal to 2 cannot you take. Why? Because if you take 2 pi means 360 plus will come. If you take 1, pi plus means it will lies between this interval. Let us check. We have pi plus tan inverse of 3 by 2 whole power 1 by 3. In this interval, that is pi comma 3 pi by 2, let us check. It will have a global, already we have global maxima here. Let us check what happens there. Maybe global maxima it will have, or global minima it will have. Let us check. Says we know that as so that is our interval. So this is equal to pi. This is 3 pi by 2. Let us approach from here left hand side, here from right hand side. Let us check what's happened. Limit extends to pi minus, that is from right hand side you are checking, plus x plus. So what is the value of this our function? 2 secant x plus 3 cosecant x. What is this value? This approaches to minus infinity. So as x value approaches to, so why? Because here secant pi is minus 1, cosecant pi is 0. Secant pi is minus 1, that is equal to minus 2. Cosecant pi is 0. This is a minus 2. That means it goes on decreasing minus infinity. That means as you are approaching, see here, so you are getting minus value, okay, minus infinity. Now let us check what happens when limit extends to 3 pi by 2 minus. That means what? You are approaching 3 pi by 2 from right hand side. So from this, left hand side, that is the left hand side limit at x is equal to 3 pi by 2 I am checking. So what is this? 2 secant x plus 3 cosecant x. This is also approaches to minus infinity. That means if you are approaching this is also you are getting minus infinity. So here you are getting what you will get, what you are getting. So therefore at x is equal to 3 pi by 2. So that means as at x is equal to, as x belongs to pi comma 3 pi by 2, at x is equal to pi plus tan inverse of 3 by 2 1 by 3. So we have global maxima. We have global maxima at x is equal to this value. So at x is equal to pi plus 2 tan inverse of 3 by 2 1 by 3, we have global maxima, that is a maximum value. At x is equal to tan inverse of 3 by 2 whole power 1 by 3, we will have minimum value. Okay, na? So it's a very interesting problem. So this is a very important. So we are checking that is we should know the art of graphical knowledge. So how to draw the graphs, that also we should know. If you know that graphical knowledge, the problem will be very easy. Okay, na? Right, I hope that you understand this solution. So let us go for next problem. Welcome to this problem. Here it is given, the problem is find the range of the function f of x is equal to 2 root of x minus 2 plus root of 4 minus x. But the range means what? Points of extrema. So maximum value and a minimum value we have to find out. That is called range of the function. So before finding the range of the function, first of all you should be keep it in mind that you have to find out the domain of this function. So what is the domain? What values x takes? So that in that domain only we will find out minimum value and maximum value. Okay, now. So let us take to find the domain of this function. As already we know, this is under square root of x minus 2 is equal to. So to define this function, x minus 2 should be greater than or equal to 0 and 4 minus x should be also greater than or equal to 0. That means x greater than or equal to 2 and x less than or equal to 4. Okay. Therefore, what is the domain of this function? Closed bracket 2 to 4. That means this function takes the values between 2 and 4 including 2 and 4. So in this interval only you have to find out its maximum value and minimum value. Okay, now. Then how to find out this maximum and minimum? What is the procedure? At maximum value and minimum value, the derivative of this function is equal to 0. That means the slope of the tangent is equal to 0. So find out f dash of x here. What is f dash of x? 2 into root of x minus 2. Root x derivative 2 root of x minus 2 plus. So this is a 1 by 2 root of 4 minus x. Again 4 minus x derivative is minus 1. This is equal to 0. Okay now. So 2 will get cancelled. 1 upon root of x minus 2 is equal to 1 by 2 root of 4 minus x. Okay. So take cross multiplication. 2 times root of 4 minus x is equal to root of x minus 2. Take squaring on both sides, that is equal to 4 into 4 minus x is equal to x minus 2. Okay now. So let us take this calculation. So this is equal to, so 16 minus 4x is equal to x minus 2. So if it is there, 3x is equal to 14. So if you minus 2 come this side, so this is equal to plus 2 minus 4, that's because this is 5x. So x is equal to 14 by 5. If you observe this x is equal to 14 by 5 belongs to our interval 2 to 4. Interval 2 to 4. Okay now, right. That means, so this is a global maxima we can call it as. So the maximum and the minimum value, so if you observe here, so this is a 2 and it is 4. This is 14 by 5. So you may get the maximum or minimum values at either 2 or 14 by 5 or x is equal to 4. Okay now, let us check one by one. So if you take f of 2, let us take f of 2 is equal to, this is a 2 minus 2, 0, 4 minus 2, 2, root 2 you will get. Okay now, next to f of 14 by 5. So if you substitute wherever x is there, substitute 14 by 5, here also 14 by 5. So you will get root 10 value. Let us check it. Wherever x is there, substitute 14 by 5, you will get root 10. For root 4, 4 you substitute here. 4 if you substitute 4, so this is a 4 minus 4, 0. So 4 minus 2, 2, 2 root 2 you will get. So 2 root 2. Out of all these three values, which will be the maximum and which will be the minimum you will have. So this is the 2 root 2 will be the maximum and root 2 will be the minimum. Therefore, what is your range? Range is equal to first minimum value. Minimum value is equal to, see here, this I think this will be the maximum value. Why? Because root 2 means 1.414, that is a 2 point. Root 10 will means 3 point something. Therefore, definitely this will be the maximum and this will be the minimum. Root 2 will be the minimum and root 10 will be the maximum. Okay. So that is the range of the given function. First, what we have to find out? We have to find out the domain. Whatever may be the function given, is asked to find out the range or extrema or minima. We have to find its domain. Understand? So we have to find out the domain, first derivative, and we are equal. Let us check whether it x is equal to 14 by 5 belongs to the domain or not. If it does not belongs to the domain, we can omit that value. We can omit, simply we can omit the value, and we can find out the maxima and minima at 2 and 4. Okay now? So let us, I hope that you understand this solution. So let us move for next problem. Welcome to this problem. The problem is, find the roots at which the function f given by has local maxima, local minima and point of inflection. Okay now. So we have to find out the roots means x value, where it this function will have maximum value and minimum value, points of fluctuation. Inflection we have to find out. So for this, what we have to do? For maxima or minima, first derivative we have to find out. So what is the first derivative here? F dash of x is equal to x minus 2 whole to the power of 4 into 3 times x plus 1 whole square. Okay, now u into v formula. Again x plus 1 whole cube into 4 times x minus 2 whole cube. X minus 2 whole to the power of 4 derivative. Now f dash of x is equal to, can I take maximum walk into here, x minus 2 whole to the power of 4 is there, here x minus 2 whole cube is there. So I can take x minus 2 whole cube Here x plus 1 whole square is there, here x plus 1 whole cube is there. So can I take x plus 1 whole square? Yes. So here what remains? 3 times x minus 2 plus here 4 times x plus 1. 4 times x plus 1 remains. Okay, na? Right. So this is equal to x minus 2 whole cube. This is x plus 1 whole square into 3x plus 4x, 7x. So this is equal to minus 6 plus 4. Minus 6 plus 4, minus 2. Okay, na? Right. So for maxima and minima, f dash of x is equal to 0. Let us see the sign scheme. So here what are the points of points of maxima and minima that we will see here. So here x plus 1 that is equal to here minus 1, 7x plus 2, see here x minus 2, this is a 2, 7x minus 2, this is equal to 2 by 7. Okay, now? So this is 2 by 7. Right. As usual, first is to see here x minus 2 whole cube is there. That's why always plus and minus, again plus, but see here x plus 1 whole square is there. So already in your lower classes, wherever IIT foundation is there, so you know the how to solve this type of linear equations by wavy curve method. So here cube is there, that's why plus minus will come. Anyway, first time plus will there, afterwards minus. But here x plus 1 whole square is there, no. So x minus 2 is also odd number, that's why minus plus. But here x plus 1 whole square is there. That's why if it is a sign is plus, here also you will get plus. That is a very, very important thing. So you will learn this in wavy curve method in the lower classes. Okay, na? IIT foundation classes. If you have gone through the IIT foundation classes, this type of methods you will have so much thing. Now coming to the sign scheme, already we explained this. For local minima, so what is the slope of, this is the slope of the tangent. So slope of the tangent means what? So this is what? Negative. This is positive. That means negative to positive will come. What the slope of the tangents? From, if you observe from left to right, negative to positive. Negative to positive where? Here at x is equal to 2, the slope will become negative to positive. Therefore, at x is equal to 2, local minima. Local minima. At x is equal to 2, you will have local minima. What is local maxima? Observe here local maxima. Local maxima means, see, observe this tangent. So this is acute angle, that means plus. Observe this angle, tangent, this is obtuse angle. This is acute angle, obtuse angle. So what is the symbol? Plus 2 minus. Plus 2 minus. Plus 2, as you are observed from left to right. Plus 2 minus. That is at x is equal to 2 by 7 local maxima. If you observe at minus 1, there is no change in sign. There is no change in sign. Plus, plus, minus, minus. Therefore, at x is equal to minus 1, this is the point of inflection. This is point of inflection. Understand what is the point of inflection means? So this is the point. So where f dash of x does not exist. F dash of x is equal to 0 or f dash of x does not exist. Okay, so that is called points of inflection. That means here, that is if you observe here, yes, from this is immediately it takes the turn. That is called point of inflection. Okay, na? Right. So at x is equal to 2, it will have local minima. At x is equal to 2 by 7, it have local maxima. At x is equal to 1 is the point of inflection by just seeing the sign scheme. So if it is a minus 2 plus, that is a minima, plus 2 minus maxima by seeing the tangents here. Okay, na? So I hope that you understand this concept, and let us go for next problem. Welcome to this problem. Let f of x is equal to sine cube x plus lambda sine square x. F of x is equal to sine cube x plus lambda sine square x. Here lambda is there. Okay, na? So, and x lies between minus pi by 2 to plus pi by 2. So remember that, so x does not taking pi by 2 value and minus pi by 2 value. It is a open bracket. So the question is, find the interval in which lambda should lie. Find the interval in which lambda should lie in order that f of x has exactly one minimum and one maximum value. F of x should have, this function should have exactly one minimum value and one maximum value in that interval. We have to find out the lambda. The lambda should belongs to which interval? Lambda should belongs to which interval, so that this function should have one minimum value, one maximum value only. Understand? In the interval minus pi by 2 to plus pi by 2. Okay, now, right. Then how to do this? That means, if you draw the graph here, so this is minus pi by 2 to plus pi by 2. This function should have only one maximum and one minimum value. So this is in this interval, one maximum, one minimum value should it have. Only one maximum, one minimum value in the interval minus pi by 2 plus pi by 2. Then what should be the value of lambda? That is our main question. Right. Let us proceed the problem. So let us see that first of all, this is a f of x. First find out f dash of x. So sin cube x derivative. So this is equal to 3 sin square x, sin x derivative cos x plus lambda into sin square x derivative. So that is equal to 2 sin x, again sin x derivative cos x. Right, we take common outside, sin x cos x, we can take common outside, sin x cos x. So this is equal to 3 sin x plus 2 lambda. Okay, now, right. So for maxima and minima, f dash of x is equal to 0. Okay, now, so here the tangents are parallel to x axis. Therefore, this implies either sin x should be equal to 0 or cos x should be equal to 0 or sin x should be equal to minus 2 lambda by 3. 3 sin x plus 2 lambda is equal, therefore sin x is equal to minus 2 lambda by 3. In this thing, sin x is equal to 0. Therefore, x is equal to 0 means x belongs to minus pi by 2 plus pi by 2. Okay. Sin x, okay, sin x is equal to minus 2 lambda by 3. Okay, we will put it like that. Cos x is equal to 0. Cos x is equal to 0 means what? X is equal to plus pi by 2. Pi by 2. But here x is not taking pi by 2. That's why this case you cannot get cos x is equal to 0. Why? Because x does not take the value pi by 2. Therefore, 3's case will be cancelled. Okay, sin x is equal to 0. This implies x is equal to 0. Put it like that. Afterwards, we will see. See this interval, sin x is equal to minus 2 lambda by 3. What is the range of sin x? Minus 1 to plus 1. Therefore, minus 1 less than or equal to minus 2 lambda by 3 less than 1. Only less than. Why? Because here x value does not taking pi by 2 or minus pi by 2. So, sin 90 is 1, sin minus 90 is minus 1. Here x value does not taking minus pi by 2 to plus pi by 2. Therefore, sin x value strictly lies between minus 1 and plus 1 only. It does not taking 1 and minus 1. Understand that also should be careful. Right, from this is a minus 3 less than minus 2 lambda less than 3. Okay, so divide with minus 2. What happens? Minus 2 if you divide, so this is 3 by 2 greater than lambda greater than minus 3 by 2. If I am dividing with minus 2, therefore the intervals will change. So we can write down minus 3 by 2 less than lambda less than 3 by 2. So this is the interval. Now see here. See here what happens. If lambda is equal to 0, what happens? So here lambda takes the values between minus 3 by 2 and plus 3 by 2. Both the values you will have. But if lambda is equal to 0, what happens? Sin x is equal to 0. Sin x is equal to 0. Therefore, f of x is equal to, f of x has only one solution. It has only one solution. Either it may be maximum or minimum. But he is saying the function should have one minimum and one maximum. Understand? It should have one minimum and one maximum means your lambda should belongs to, for f of x to have one maximum, exactly one maximum, one minimum, exactly one maximum, one minimum, your lambda should belongs to minus pi by 2 to 3 pi by 2 except at 0, except 0. Why? Because at 0, if lambda is equal to 0, here sin cube x only will be there, sin cube x will have only one maximum value or one minimum value. But if you remove that 0, so from between minus 1 by 3 to 3 by 2, minus 1 by 3 to 3 by 2, if you take any value between minus 1 by 2 to 3 by 2, here the function will have either one maximum or exactly one maximum or one minimum value. Okay, now, right. So, this is a very, very interesting problem. So, I hope that you understand this solution. So, dear students, I hope that you enjoyed today's class with some more problems, and I will come before you. Until then, all the best.